How many 3-digit numbers can be found from the digits 1, 2, 3, 4 and 5, assuming that repetition of digits is allowed, repetition of digits is not allowed? So what is the question? Let me break down the question for you guys. So what we are looking at is we have ones, tens and hundreds place that has to be filled with what? 1, 2, 3, 4, 5. In one of the case there is a repetition that is allowed, and in another case there is no repetition allowed. I will start off with the non-repetitive scenario. What does it mean? So let me explain it with this animation. I have 3 boxes similar to what we are looking at over here, 100, 10 and 1's place. Again, you can think of this as people, objects, numbers, anything, alphabets, anything. So what is happening over here? Well, I will allow one object to be placed over there. So that moves out of the group, right? That moves out of the group. Remember, repetition is not allowed. That's what it means. Okay. So once used, it's used. So for the next box, there are 4 options and I'm putting a random one. Then how many is left out? 3 is left out. And 3 move across and we may make use of one of it. And thus we have filled all the 3 boxes. Now the question is, by using the fundamental principle of counting, can you guess how many numbers, such numbers are possible? How many such combinations are possible? Think of it. It's a very simple thing. Think of this as starting from over here. Imagine here that will branch out to 5 different branches, and each of this branch will have how many branches? 4 more. And each of this branch will have how many? 3 more, right? So basically it would be, yes, 5 into, correct, 4 into 3. So basically it is 60. So there's 60 different possibilities. Okay. Now let me show what does it mean by repetition is allowed. Oh, sorry, I didn't. Wait. This is non-repetition with repetition. Yeah, this one. Right? What is happening over there? I made use of this, but that didn't disappear. Are you getting that? That didn't disappear. Again, the entire 5 bunch moved across. And again, I'm using a random number. Right? Can you see that? The green was used, but the entire group moved across, because even though it was used, it can be replaced. And so we still have all the 5 options ready for us. So I have 5 different options for this box as well. Right? Now can you think of, with the help of fundamental principle of counting, what is that we're looking at? Right? So we're looking at, here we're looking at 5, here too we're looking at 5, and here too we're looking at 5. So 5 into 5 into 5 is our option answer. Okay guys, so let me re-explain all of this with the numbers. So I have 1, 2, 3, 4, 5. Remember, I'm answering the second question without repetition. So I can fill with 5 different numbers over here. Say I chose 2. So what happens? The 2 will disappear. Okay. Now, so I just have 1, 3, 4, 5. So what to fill over here? Maybe 5. So 5 will disappear. This is without repetition, remember. And then I am left out with 1, 3, 4. Say fill it with 1. And so we're looking at 152. Right? This is one possibility. Here 5, 5, 5. Or 4, 4, 4. Or 2, 2, 2. Such numbers are not allowed. Say 5, 4, 2, 4. This is not allowed. Does it make sense? Okay. So point here is I'm able to fill with 5 different numbers over here, 4 different numbers and 3 different numbers. Again, the order does not matter. I'm just showing you guys the concept. I can fill this first and then this and this, then that. Not an issue. So our answer will look something like this. As we have 5 digits in the ones place, we can fill it with, we can fill it with 5 different digits. In tens, it will be 4. In hundreds, it will be 3. Option. 4 options. Okay. So end of it. Therefore, we will have 5 into 4 into 3. That is 60 different possibilities. Okay. So basically, this would be our answer. Okay. Now, let's look at with repetition. What if we are allowed to repeat? So we have 1, 2, 3, 4, 5. Now, let me place, say, 5. What will happen to the 5 over here? Yes, it is not used up because we have infinite number of 5s, infinite number of 4s, and so on and so forth. So I can place 5 again over here. Right? This is possible. This is with repetition, remember. And here 3. Again, nothing will happen to this bunch. It will continue to be present for all the digits. So basically, as repetition is allowed, right? So I think the repetition of all the digits 1, 2, 3, 4, 5, right? For 3-digit number. Okay. So as repetition is allowed, just a second. Repetition is allowed. We have 5 into 5 into 5. That is 125 different possibilities. Okay, so that would be our answer. It's a very important question to begin with. If you're able to understand this, you pretty much can answer all the difficult questions. I can promise you that. But please understand you have to understand both of it actually. This is very important because you guys get confused with this. With repetition, that is not that confusing though. Okay, you have to learn all of this. Yeah.